Okay, so this one we're going to go over 647 palindromic substrings. Right, and then in this question we're trying to count how many palindromic substrings are in the string. Different sentences are kind of different. So in the character like ABC, there's 3 palindromic substrings. There's A, there's B, and there's C, right? In ABA, there's A, there's B, there's A, there's ABA, so there's 4. So this one has 3, this one has 4. So we're just gonna skip like the slower solutions, and we're gonna use our previous solution related to Manacher's algorithm. And I still don't actually fully understand the concept, but I have it like somewhat memorized. And I understand parts of it, so I'm just gonna, I think it might be good to try and brain vomit that onto the board. So let's do that. So Manacher's algorithm essentially, like given that string, let's say A, B, C, B, A, what you're doing initially is, so let's say this is S. You wanna change this string because you need to check if it's a palindrome from here, from here, from here, from like within the middle of those characters. And a simple way to do that is to just add a character in between everything and denote like a start and end index. So what you can do is say P, let's use something else. Let's say T is equal to, what you're trying to do here is like add a start. Yeah, I was gonna do this in like a hard to read way, but this is what we're trying to create. So like start sign, and then what we're gonna fill in between our characters, something like that. And then at the end, like an ending character, right? So we'll say T. So we'll define this function first. Count pal substrings. We're taking in a string, and that's all we're taking in. And then we'll define our helper function. This one should be short, so the helper function, which is the actual Manacher's algorithm, that's going to be the longer one. So let's just write that up here. Manachers. So we'll set T is equal to $pound plus dot join S plus £, ending sign. Right, so that should give us this. P is equal to this. And from here, what we want is we need a right border and a center. Center to keep track of how many instances we can move, either left and right, until it's not a palindrome, right? So for example, we're going to start our right border and center at index 0 here of T. And then this would be the center at first, and then we're going to iterate over to the right, and this is going to be like if we're using this as our center, we would see that $ and A are different, so it has a palindrome length of 0, right? I mean, this is a palindrome of itself, but everything is. So, but this is just number sign, so we're going to say it's 0. So in order to do that, we need to keep track of a different index that keeps track of how many instances left and right something is a palindrome. Because if we're at A, then the £, are the same. So we would have like 1 for A, and then at B we would have 1 as well. At C we would have 1, 2, 3, 4, 5. So we would need to keep track of that somehow. And how we do that is inside this P array, I guess P for palindrome. And then we can initialize this at first, the zeros. How we start writing diagonally here, because I want you guys to be able to see. Okay. Yeah. So the idea here is to reduce adding on more of these when we've reached like the middle. We already know that everything that's on our left should be like mirror to everything on our right. So there's just one piece of line that I don't really quite understand how it works. So hopefully I can remember it and we can see how it works as we go through. But for now, there's like this right border and a center that are both equal to 0 at first. And we've set t here. I'm going to write p 0 times the length of t. Right, and now we can iterate through. So for I in range of length of t minus 1, this is the mirror that they're saying works to do putting the left side onto the right side. But let's see if we can understand, reason the logic behind it. So it would be 2c minus I. 2c minus I? Yeah, and then we'll do if I is less than r, which is the right border, then they said p of I is equal to the min of p at, because it's 2 times the center minus I. I guess, yeah, that does make sense. P of mirror and it's r minus I. Right, so I think that's right. And here we do, so we need to check at like a given index how many times we can move over to the left and right. And a pretty cool way to do that is to do like a while loop like this. So we'll set a while t of I minus 1 minus p of I is equal to t of I plus 1 plus p of I. So this means like we're at index 0 here. T of I is 0 and p of 0 is also 0. Well, they're equal to each other. Well, we wouldn't even start at index 0, so we could start at 1. Actually, it wouldn't matter. But if we start at like this index, wouldn't matter either. We would go there. Oh, and this should be out here. Yeah. So right here, t of I minus 1, I is 2, 0, 1, 2. 2 minus 1 is this, minus p of I, which is 0. And then t of I plus 1 is 3, plus p of I is 0. So we're at this and this. While it's equal to each other, all we need to do is increment p of I, and then we'll move both to the left and to the right. So we'll set p of I, and this also keeps track of how many lengths from this character we can go that still make it palindromic, whatever. P of I plus equals 1. And then at the end, what we need to do is if our I is greater than r, if our index has passed our right border, then we need to update our center to be equal to I, and then we need to move our right equals I, not just I, but I plus P of I. So why are we doing P of I? So let's say we're at here, this is our center, or we would just have to start, let's just start from, this is all the function, so let's just go over the code. So we would just return P, right? So let's go over it. So R and C start at this, start at index 0, we have P initialized here. So for I in range of T minus 1, if I is less than R, no, I is 0, R is also 0, no. While these are equal to each other, no. If I is greater than R, no. So we go to the next iteration. And then mirror is here as well. Yeah, I guess you could just put that in there. So yeah, now we're at index 1. If I is less than R, no it is not. P, so we don't do this. While they're equal to each other, the left and right are, no they're not. If I is greater than R, yes it is. Then we update C is equal to I. And then R is equal to I plus P of I. So we update C. So this is now our center. And then R is equal to I plus P of I. So no, it moves as well actually. Yeah, it stays at where I is. So now we go to our next iteration at A. A is less than R. No. While T of I is equal to T of I plus 1, or T of I minus 1 is equal to T of I plus 1 plus P of I. We want to increment P of I. So they're equal to each other, so we increment it once. So now we have this. I is greater than R, yes it is. C is equal to I. So move our center to here. And then R is now equal to I plus P of I. So move it over 1. Move it over 2, but one from the center. So this is R. So now we have our center and then our right border. So it looks like it's working. And let's just continue. Let's just continue the iteration all the way. So now we're at here, index 4. 6, 7, 9, 10, 11, 12. Index minus 1. Well, we can keep it there. Whatever. Yeah, now we're at 3. I is not less than R. While they are equal to each other, they are not. If I is greater than R, no it is not. So we skip that iteration and keep that at 0. So now we're at here. I is less than R, no it is not. While they're equal to each other, increment P. It's only one time that they are equal to each other, the right and the left. I is greater than R, let's update C. And update R. C is I plus P of 1, which is here. So R is here. So that's our right border because that's how far the palindrome goes from that center. So that's looking good so far. And then our next case should be interesting. Or not our next case, the case after that. No, that is right. So we're here. Wait, where are we here? We're at B, right? No, we were at the pound sign. No, we were not. We were at B, I hope. So let's just say we're at B, and I was greater than R, which it was, so we updated C, and then we moved to R. Yeah, that's right. So now we're at this pound sign. For I is less than R, it is still not less than R. While they're equal to each other, they are not equal to each other. I is not greater than R, so don't do anything. Now we're at C. So now that we're at C, I is not less than R, while T, left and right are equal to each other. Yes, they are. We'll continue to increment P of I. So 1, 2, 3, 4, 5. From here, we can move 5 times, and as C is our center, it is palindromic, 5 sides to the right, 5 sides to the left. So I is greater than R. It is. So C is now equal to our new center, which happens to also be C. And then we're updating our right border. And just like thinking about it, our right border should be that many times from our center. So it's I plus P of I. So we'll move 5 times. 1, 2, 3, 4, 5. Which makes sense. I hope. So now we are there. And we can continue the iteration. And then this is where our mirror should save us runtime. So I in range. So now we're at here. I is there. 7. I is less than R. So P of I is equal to the minimum of P of mirror. So P of mirror would be 2C minus I. So it would be 12 minus 7, which is 5, right? So at this one, the mirror from there should be this one. So it does make sense. So that would be 0. P of 5 is 0. Is 0, and it's the min of that, or the right minus I. So 11 minus 7, which is 4. (11 minus 7, which is 4. So the min, why would it use that one as well? I wonder. Well, let's carry on, because let's see. Why are we doing R minus I? It seems like it would just be the mirror. I think it might be a case where it's something like CBA, and then you have something afterwards. Maybe, because you can't use like the mirror. If you have something like this is your mirror. You can, this B should be the same as this B, and this A should be the same as this A. But this A and this B are going to be different. I think it has something to do with that. But yeah, for this purpose, let's not waste too much time on this video. So yeah, it's going to be 0. I'm going to change this to 0. Using the mirror, it should be the same thing. So this one should actually change to 1. So let's just go over how that would work. So for an index 8, yeah, and I is not greater than R until here, so we don't really have to look at that. But when we're at this, it's always going to be less than R. So the mirror is going to be 2C, which is always going to be 12 minus 8, which gives us that. So yeah, that makes sense. Why that's the mirror. Should be 4, and then this one should be 1. And then let's see here actually. So R minus 1 in our case it should be greater than or equal to 1, because we're getting the min of that. So R is 11 minus 8 should be 3. So it's saying that is 0, so that's weird. I is less than R. No, it's actually changing this to 0 at first, right? Because P of mirror is 2C minus I, which is 12 minus 4, which is 1. That's what we thought it would be. But R, 11 minus 8 is 3, which is 0. So we're saying that's 0 for now. So that actually doesn't mess it up yet, because we'll go to this while loop, See that they're equal, so we would still update this value to be 1. It's strange. Well, it seems actually even without these lines of code, it would still work. But I remember when I tested it, it ran a lot slower without this. Yeah, I'm gonna have to look it up a little bit more. But yeah, this works, and let's just finish solving the problem. So we're returning something that's like this, and we'll just quickly change these 0, 1, 0, 1, 0. I think I'm missing a 1 somewhere. 1, 2, 1, 2. 1, 2, 1, 2. Okay, that's odd. I think that's good. We'll leave that at that. So once we get this, what we want to know is we need the count of our previous problem. Was this palindromic substring? We're not just doing Manacher's algorithm. So given a string like this, how many characters are palindromic? And that should be 1, 2, 3, 4, 5. 1, 2, 5, 6, 7. Should be 7. Right, so we can actually get that derived from this. What we need to do is just iterate through this array. Anytime there's a number equal to 1 or greater, we can add 1 to that number and divide it by 2. So for example here, let's say 2 divided by 2. Here, 1 plus 1 divided by 2. 5 plus 1 divided by 2. 1 plus 1 divided by 2. 1 plus 1 divided by 2. So this gives us 1 plus 1 plus 3 plus 1 plus 1, which is 5, 7. Right? 1, 2, 3, 4, 5, 6, 7. So this is our number. This is our answer. So all we need to do is, in our main function, we will define main, some sort of string, and we'll go count is equal to, it's a keyword in Python, do res or total equal to 0 for n in Manachers s res plus equals n plus 1 divided by 2, and it's not slash slash, it's just divided by 2, so that if it's like 3, we still want 1. If the number is like 2 plus 1, that's going to give us 1. If it's also 1 plus 1 divided by 2, it's also going to give us 1. So, and that's handling like the cases that we have all these pounds. So that's the reason why we're doing plus 1 divided by 2. So we're going to do that, and then that's going to be our solution. So Manachers are going to go over these elements once and create this array, and then we're going to go over that array once. It's going to be O of n plus O of n, which is just constant, or linear time O of n. So return res should give us that number. For this one, it should be 7. Yeah, that's going to be our solution. Apologies for not being able to explain this too well. I'm going to go over and see how I can improve upon that and see why this saves some time. I think it's just this specific line that's confused me in a way, because it seems like this one should just automatically change to 1 and then stop. We probably wouldn't. It seems like this is a waste after we do that. Let's see. So we change this to a 0, and then this would update the p of I. This updates the p of I would potentially change that, so that might be how that's going to save time, because we've already known how many times we've seen it, so we wouldn't have to move as much. That kind of makes sense. That's probably it. But I'm going to stop the video here and examine further myself. Thanks.